cut off from math manipulatives in school sometime in the 5th grade, the tactile learner is at a loss for their math comprehension. Maybe they can get through geometry with 2D and 3D shapes and geoboards, but then we get to triangles and there's no hope. With the tactile graph, I hope to solve a part of this problem as I bring my invention to market. Finally, a math manipulative for algebra, calculus, and dare I claim, differential geometry. If you're a tactile learner, you might own sets of counting blocks, rods, base 10 blocks, clocks, or fraction tiles. These math manipulatives are particularly useful for understanding numbers and arithmetic. While a useful skill to learn so you're not stumped at the grocery store, I perceive a calculator can do this task fairly well. Before the calculator was the slide rule, and before the slide rule was the abacus. As long as students have a grasp on numbers and that they understand the operations enough to use the calculator, they should move on to higher dimensional manipulatives. This method is what's known as the concrete to representation to abstraction, or the CRA method. For Christmas one year, Austin got me a TI Inspire calculator. This calculator was nifty and could do all sorts of math, including 3D graphing. Unfortunately, I had just moved into the version of math that neglected calculations and instead required proofs. I shouldn't call it unfortunate because I love that side of math, but when we are no longer fixated on operations and are instead exploring high-dimensional geometric problems, my brain is most tickled. Featured in this post is one of my note pages from Advanced Linear Algebra, a class I took in my senior year of college. I actually copied an entire semester's worth of relevant information with 65 theorems, 26 definitions, and 23 homework problems onto these 2 pages. My professor allowed us unlimited time on these exams, but students rarely took longer than 2 to 3 hours. I know that sounds like a long exam, but she didn't host them often, and there were only 6 questions. She said you would get graded on your best 4 problems, and she would grade every piece of work that you submitted. When she said I could use theorems from the book to prove my claims, I took the challenge to get every relevant theorem on the front and back page I was allowed to have during the test. My professor hosts her exams this way to accommodate students who need more time on exams. She said you only had to pick your favorite 4 of the 6 questions because some students had that accommodation too. By catering her exams to the needs of her students, her test proved to be the most fun for me. I took her up on her offer of these advantages, and they proved to be useful considering I aced her class. Not only did I engage deeply in her class, but I also used the pictured material paired with the tactile graph to get a grasp on the quantum mechanics and cosmology and gravitation courses I was taking at the same time. While engaging in those courses, I worked hard to learn them together. These concepts all work together to talk about the same core concepts for me, geometry. This fundamental class is represented with math manipulatives like geometric shapes, geoboards, pattern blocks, and tangrams. These shapes move into 2 and 3D thinking. As I used the tactile graph, I began my learning in the constructive phase. Constantly building vector spaces enabled my representation of the mathematical form. As abstract as those notes appear, they make sense to me because I utilize the CRA method to learn. By creating pictures of flowers with the pattern blocks and tangram manipulatives, you might start to learn about curvature, shape, differentiation, and symmetry. When graphing your pattern blocks on the tactile graph, you might expand your understanding of how numbers and geometry work together to form higher dimensional math skills. Additionally, you could use the circular version of the tactile graph to understand trigonometry. I built this version with the intent to help memory of the unit circle. By utilizing the concentric circles, you might find solutions to E&M problems involving wires or orbits. I am glad to have married into a family of creators because my sister-in-law made me these stickers, and I'm waiting to get over a cold to print the missing ones. Geometric shape manipulatives can be used on the tactile graph to find the volume, surface area, and perimeters. In fact, if you have the ability, I recommend writing the common formulas on your geometric shape, so memorization doesn't hold you back from comprehension. I can see how the current tool sets can work in tandem with the tactile graph, and this tool could be a good addition to your tactile learning experience. However, in today's literature, I read that they are testing math manipulative outcomes for undergraduates. But can you guess what kind of math manipulatives these tests use? One study used perceptually rich manipulatives and bland manipulatives, such as place value, blocks, beads, and drinking straws. Another study, entitled An Exploration of Manipulatives in Math Education, used 10 frames and algebra tiles. These tools might also work in tandem with the tactile graph. However, this paper suggests more research and surveys be conducted instead of innovating in the math manipulative space. Math manipulatives can develop hands-on measurement skills. They can also be used for conceptualizing geometry, which you may need if you're a day-to-day creator of cool things. I know I use geometry every time I construct a new 3D print, which has resulted in the construction of the tactile graph. Skills like collaboration and perseverance might also improve with the use of math manipulatives. The above study about perceptually rich manipulatives, meaning textured and brightly colored tools, showed that when students collaborated, they were more willing to spend more time thinking about a solution when they were using manipulatives versus when they were not. Manipulatives also enable creativity. With geoboards and tangrams, you can make unique pictures. With the tactile graph, you can use those shapes to construct real-world dioramic sets to contain the elements of your problem. This use case means that you can utilize the grid pattern and modular inserts to model 3 and 4-dimensional problems such as kinematics and E&M. The creativity does not stop at solving problems, as you can also use these tools to create high-dimensional art. By using a crochet hook and some yarn, you may be able to graph high-dimensional structures, like in the math art book my stepmom got me for Christmas a couple years ago. And here are some of the benefits of math manipulatives. I often read that people might need math manipulatives to comprehend abstract concepts with concrete tools. While I agree with this sentiment, I rarely read about the benefit from the movement associated with manipulatives. If you tend not to move when you're learning something interesting, then this value might not be obvious. However, those of us who can't stop shaking our legs might get some more engagement just from the movement. I remember in a college class, I accidentally chucked my pencil across the room, and it landed right in front of my professor. He kept talking while he picked up my pencil and passed it back to me so I could continue taking notes. I wasn't intending to distract my classmates by being a goofy class clown. In fact, I was so engaged in his lecture that I unconsciously started shaking my pencil in my hand. Often when I'm learning, I have to move. Instead of clicking my pen or shaking my leg, which often causes distracting noises, I learned to shake my pencil like a seesaw between the two fingers I write with. When I got too focused in that instance, I gained more momentum than intended, and it leapt out of my hand. I didn't notice the speed I had accelerated to because of the fascinating math that was in front of me. That wasn't the first time I accidentally threw my pencil during class, and it certainly wasn't the last. For those of us who can't sit still, manipulatives provide the opportunity to move while staying engaged in the lecture. Do students need manipulatives? I think that depends on the student, since not everybody is a learner who needs movement. For those of us with those needs, if we keep our hands busy, we have less opportunity to accidentally chuck pencils across the room. Additionally, manipulatives can help students develop hand dexterity. Many people, like mechanics, surgeons, and cooks, need their hands to conduct their work. Math skills are essential in all of these roles. If you are a tactile learner, you've probably found yourself in a role that requires hand dexterity. Enabling the use of math manipulatives means learners can develop both skills at the same time. Additionally, neurodivergent students often like to use fidget toys in the classroom. However, the research is inconclusive on whether these toys help them focus. If your fidget is instead a tool related to the concepts you are learning, does that satisfy the same itch? From a literature review done on 36 studies of math learners with spectrum disorders and learning disabilities, using the CRA method with math manipulatives showed to be highly effective as an intervention strategy. While these students varied in quality measures, effective size, grade level, and the disability or disorder type that they had, all students improved in the math skills measured. Of the 36 studies, 11 of them were conducted with middle or high school students. Of these 11 studies, 2 used only virtual manipulatives, 1 used virtual and concrete manipulatives, and 8 used only concrete manipulatives. The concrete manipulatives used for these 11 studies were algebraic balance scales, plastic money, geoboards, algebra tiles and blocks, paper and plastic plates, plastic counting discs, Unifix cubes, beams, fraction tiles, and squares and sticks. Despite these students all improving when using manipulatives, graphing concepts are not able to be taught thoroughly with the current manipulatives on this list. Lack of tools does not mean the tool stops being useful in higher level math. Even the students using sticks for transformations still showed improvement. The tactile graph is just an upgrade from the sticks. Math manipulatives can also improve spatial reasoning and measurement skills. Utilizing tools like a tape measure are common for a contractor, and this skill was likely taught to them using a ruler in math class. Similar tools like protractors and squares can be compared. I once saw a TikTok where a builder used the 3-4-5 triangle to prove a structure was square. Because math is so physically relevant, there really is no way to avoid it in everyday life. Whether you build, bake, or calculate, you will at least need basic graphing skills to continue doing so. I am excited to bring my tool to market to enable strengthening in measurement, dexterity, focus, and overall math skills for the tactile learners. Feel free to keep following for more content about the tactile graph. I would love to get this tool in the hands of the tactile learners. So make sure to subscribe and follow me on social media. Keep updated with my current campaign to get this tool to market.